Bismillahirrahmanirrahim. In this video, we'll discuss about autotransformer. Now, what is autotransformer? On some occasions, it is desirable to change voltage levels by only a small amount. For example, if you want to increase voltage from 110 to 120 or from 13.2 kV to 13.8 kV, then we can use a special transformer which is called autotransformer. And the basic concept is, now this is the normal transformer. You see, you have a primary winding and we have secondary winding. Now if we take this one and mount it at the top, so we'll get this circuit, and this circuit is now will be called autotransformer. And couple of things related to autotransformer is, now this configuration is what is called voltage up transformer, or here the input is increased, and or a step up transformer, but this configuration is step down configuration. Same thing, we are now taking the output from here and the input is connected here. So these are the two configurations. And now this is a normal transformer with two windings, primary and secondary winding, and this is auto transformer. One winding is wound over the other winding. Now, one important difference between the two winding transformer and the auto transformer is that the windings of two winding transformer are electrically isolated. Now, there is no connection between the two windings in case of a two winding transformer, whereas those in auto transformer are connected directly. Now, in auto transformer, the primary and secondary are connected directly, so they are not isolated. So in situations where we require isolation, we cannot use auto transformer. And couple of points. In two winding transformers, there is only inductive power transformer. So due to magnetic flux linkage, power is transformed from the primary side to the secondary side. But in auto transformer, part of the winding is common to both primary and secondary. So this winding, and C means common, is common to both primary side and secondary side. The total power transfer consists of inductive transfer and conductive transfer. Now what does that mean? So if this one gets magnetized, its flux line will link the upper one. So there will be inductive transfer of power, and conductive transfer, because it is directly connected to the load, so this will be direct conduction of power. So there are two types of power transfer in auto transformer. And same thing, explanation little more. In auto transformer, there is an additional power transfer on account of physical connection between source and load. So the physical connection between source and load makes sure that additional power is transferred through the series winding. Now this is the series winding. This conductive power transfer, that is the one which is going directly, is the main factor responsible for massive saving and increased in kVA output of the auto transformer as compared to the two winding transformer. So we'll see this, how is the saving done and how is the more power achieved in case of an auto transformer. And now a couple of terms. You can see this is VP, this is NP, or also called NC, a primary winding, or the common winding. This is the first winding. no more, we can't call it common winding here, but it is actually equal to common winding of this transformer. Similarly, this is secondary winding, and this will be equal to NSE, that is series winding here, when we take it up, when we add it and we get this configuration. Now this is the series winding SE, or also calling second winding, and this is the common winding, we're calling it first winding. Now the voltage here, which is common on both sides, is called VC. This is VL, that is lower side or the primary voltage, and this is V common. The voltage across the series winding is called VSE. And this is the low voltage or VL, and the combination of the two voltages is actually the high side voltage or VH. Now we can see from here that VL is equal to VC, that is V of low voltage is equal to the common voltage, whereas on the high side V high is equal to VSE plus VC, so VC plus VSE. Also look at the current, IL current flowing in, it is dividing into two paths. So we can say that IL is equal to IC plus ISE, IC plus ISE. And IH is actually ISC. Now this is IH and this is ISC, so same current. We also know for general transformer that the voltage ratio, that is V1 over V2, is equal to N1 over N2. So keeping this in mind, we can also write that the V low over V high is equal to this turn ratio NC divided by the sum of the turn ratio, so NSC plus NC. And we know that in case of a current, the turn ratio reverses, so this one will go at the top and this one will come at the bottom. So IL over IH is shown here. Okay, now we'll see what are the power rating advantages of an autotransformer. Now in this figure we can see that the input apparent power of an autotransformer Sn is VL into IL. So this is the input power. And the output power is voltage, high voltage VH multiplied by the current. Remember, we are talking of apparent power, that is why we are using symbol S for apparent power. We also know that both sides of the transformer power are equal, so Sn is equal to S out. And this in the book has been given another name, he's calling it SIO, that is input and output, they are same. But I prefer to call it S auto. There is a lot of confusion with all these things. It is better to write it as autotransformer or power of the autotransformer. Keep in mind that the autotransformer was made by connecting the primary and secondary terminals of a normal two-winding transformer. So this is normal two-winding transformer, and we put it here, added them together to get the autotransformer. So power ratings of the individual windings can be written as primary power and secondary power. So this power is primary power and this power is secondary power. We call them S2, and the power will be equal on both sides. So the apparent power ratings of the transformer windings, we can write it as SW is equal to VCIC, one side, this is VC and IC. It is also equal to the second side, that is VSE ISE. And I'll prefer to write it as S2 winding transformer. So this is two winding transformer, just to distinguish between S auto and S2 winding transformer. So we had found this relation. Now what we are interested is to find the relation between the auto power, auto transformer power, and the two winding transformer power, which in this book has been written as SI0 and SW, but I prefer to write it S auto and S2 winding. Now S2 winding is, from here we can just write VCIC, and also S input output or S auto is also equal to S in, which can be written as VLIL. This is the auto power. It can also be written as VHIH. Okay, now we'll take this one and we'll try to find it or relate it to autotransformer. This formula VLIL. What we want is SW is VCIC. We want to relate it with VLIL to get the relation between the autotransformer power and the two winding power. Now this is two winding power. Now from here IC is, you can see IL was IC plus IH. IL is IC plus IH. From here we can write IC to be IL minus IH. So we plug this in. So we get this term. Now this is in terms of VLIL, but this one is not. So we have to also make this in terms of a VLIL. Okay, to do that, we now know the relations we had seen in the previous slide. The relation between the two currents, IL over IH, was given by this relation in terms of a turn. So from here, IH can be written as IL into this term. So we plug in this value here. So plugging in and solving, so we get this relation. Now this is the relation between the two winding power and the auto transformer power. And from here we can write S auto I0 divided by S winding, and to be more clear, we know that this is the ratio of auto over two winding transformer. So we'll use this to calculate to do the mathematical calculation. So this is the relationship between the two windings and auto transformer. Now let's do a very simple example. This has been taken from a book by Mr. Sadat. Very clearly he has explained a two winding transformer is rated to 60 kVA. So the transformer is rating to 60 kVA, that is the power. 240/1200, that means input is 240 volt and output is 1200 volt and 60 hertz. And there are some more things not relevant. This transformer is to be used as a 1440 over 1200 volt step down auto transformer in power distribution system. So how do we get the auto transformer? We will connect this at the top to get this relation, but we'll first of all, assuming an ideal transformer, find the transformer kVA rating when used as an auto transformer. So we have to find S auto. Now for the two winding transformer, you can see that the current is the kVA rating divided by voltage. So 60 kVA divided by 240. So primary current or I1 current is 250 amperes. And similarly, I2 current or the secondary current is 50 amperes. And so we can now redraw it with the currents. So 250 amperes and 50 amperes. And now when we connect this, now because we are going for step down transformer, so this is the step down configuration, and we want output to be 1200, therefore this one will be kept at the bottom and 240 or the primary will be kept at the top. So now our input voltage is 1200 plus 240, so 1440, that is what we want as the primary, and the output side will be 1200, so 1200. So this configuration is fine, and we have put in all the values of the currents here. Now this current, now you can see IL is sum of the two, which is 300 amperes. So the autotransformer secondary current we have found to be 300 ampere, and now we can find the windings rating of the autotransformer, that is the 1200 is the output multiplied by this current, so this is 360 kilovolt ampere. So S auto is now 360 kilovolt ampere. What was the S2 winding? 60 kVA. In this case it has become 360 kVA. So how much is the gain? The power advantage of the autotransformer is S auto divided by S2 winding, 360 divided by this 60, that is 6 times. Now what does this mean? This meaning is that when a two-winding transformer which could maximum handle 60 kVA is connected in the autotransformer mode, it can now handle 360 kVA, so 6 times more power. So this is a great advantage. And okay, now we come to example 2.7. So this is the question given. Now this is not very clear, so to clarify the question I have rewritten, I have incorporated some terms here. So first of all, is saying 100 volt ampere 120 by 12 volt transformer. So I have written it, it is actually the two-winding transformer, is to be connected so as to form a step-up transformer. So this is our two-winding transformer, and this has to be connected to form a step-up transformer. And how we'll connect to form it step-up? Like this. So this is the input side and this is the up side, step-up side. A primary voltage of 120 is applied to the transformer. Which transformer now? The autotransformer. 120 we are applying. What is the secondary voltage of the transformer? So that is the first question. We have to find the secondary voltage, or VH. Then what is the maximum volt ampere rating in this mode? So we have to find VA of this mode. We know the VA is 100 volt in this one, but auto VA we have to calculate. And the third one is the calculate the rating advantage of this transformer. So we just saw in the previous example, the rating advantage was 6 times. So here also we have to find the rating advantage between the two-winding transformer and the autotransformer. So first part, what is the secondary voltage of this transformer? We know this is the formula between primary and secondary, or high voltage and low voltage. And from here, high voltage can be written as shown here. And now we'll plug in the value. Now see, the primary is 120 and the secondary is 12. So the turn ratio will also be same. So we'll, for the secondary or SE, we'll write 12. And for the primary, we'll write 120 divided by 120 and multiply by the low side voltage 120, and therefore the out voltage, or VH, will be 132 volts. So this is the first part. Okay, what is the maximum volt ampere rating in this mode? So we'll exactly follow the previous example. This is the transformer. We find the currents. Current will be S2 or the power of the two windings. So that is 100 VA divided by the secondary voltage 12, so 8.33, and the primary also the power rating divided by the primary voltage, 0.833 ampere. And so these are the now two currents we have shown here. Now the autotransformer constructed from two winding transformer is shown here. Now this is the autotransformer. We have taken this up, and this is the autotransformer now, and all the currents are shown. Now the secondary voltage we found out to be 132 volt, this one. You can also get it directly by adding the two, 120 plus 12, 132. The secondary apparent power, or S out, can be written as V secondary, I secondary, or V high, I high from here, which should also be equal to the input power, which is also called SI0, and which also I am calling it S auto. So Vs secondary 132 volt, I secondary 8.33. So multiply by this, we got the auto voltage or auto transformer power to be 1100 volt ampere. Note, in the two winding it was 100 volt ampere, but in this case it can handle up to 1100 volt ampere. This is the same transformer, just when connected in auto mode, the power handling capacity has increased. And then the final question is find the rating advantage over the two. So just like the previous one, the power advantage S auto divided by S2 winding, 1100 divided by 100 from here. So 11 times power advantage we are getting in this case. Okay, now another concept that we have to keep in mind. This was the, let's say this is the transformer. Input voltage 200 and output volt we want 220. So we can use a two winding transformer. This primary side will be carrying, because its kVA rating is 10 kVA. So the primary current will be 50 ampere and the secondary current will be 45.45 ampere. If we connect this into this mode as an auto transformer, then what is happening? The current remains same, primary current here, the secondary current, but current in this winding is reduced to only 4.55 milliampere. So in addition to, if we connect this transformer directly, then this winding should be heavy to handle 50 amperes. This winding should also be heavy to be able to handle 45 amperes. But when we construct an auto transformer, then we can make this winding of very light wire. It should only be able to handle 4.55 ampere, and this will of course be made with heavy wire. So this is what is being said here. If the voltage adjustment is by a small amount, either up or down, Vp and Vs are nearly equal. The currents Ip and Is are also nearly equal. Therefore, the portion of the winding which carries the difference between the two currents, so this portion of the winding, can be made from a much smaller conductor size, since the currents are much smaller, saving the cost. So one we are getting the power advantage and the other we are saving the cost if we construct ourselves, if we just don't add the two terminals of a normal transformer. So this is one advantage of the auto transformer. And now quickly, question about the internal impedance. This is the question. A transformer rated to 100 kVA, 12 1.2 kilo, so 12 kV primary, 1.2 secondary. When operated as a conventional two-winding transformer, under these conditions, its series resistance and reactance are given to be 1 and 8% per unit respectively. So the series and series reactance and resistance are given with this ratio. This transformer is to be used as 13.2 12 kV step down transformer. So like this, we have to connect it like this, and this input voltage will now be 13.2, just addition of the 2, and the output is 12 kV. In the autotransformer connection, what is the transformer ratings when used in this manner? That means we want to find the S auto, and then we have to, what is the transformer series impedance per unit. So S auto we have found already, we'll follow the same technique. What is the autotransformer's rating or power rating when used in this manner? So we'll straight away go to this formula and plugging in the NC and SC ratio. From here you can see it is 12.12 and 1.2. So the ratio will be 12 ratio 1.2 or 10 ratio 1. So plugging in for this 1 and this 10, so S auto we can find to be 1100 kVA. So this is the first part. Again you can see that from 100 kVA we have gone to 1100 kVA, 11 times advantage. Okay, now under these conditions, if series resistance and reactance are given as 1 and 8% per unit respectively, so what is the transformer series impedance per unit? So what is the auto transformer's series impedance? Now the transformer impedance per unit as given is 1 and 8, so the real part is 0.01, 1%, and the imaginary part is 0.08% per unit. And the auto transformer has the advantage of 11 times. This was the auto transformer power, this is the two windings power, so 11 times power. So we can say that the impedance will reduce by 11 times because the power is increasing, so impedance will reduce. So the new impedance of the auto transformer will be this impedance divided by the power advantage. So this is the equivalent impedance of the auto transformer. So I hope this gives you an understanding, although it has gone very lengthy, but with step by step you can pause and then learn. Give me a feedback. Thank you.